All right, it's getting recorded. Um, today we will be today we will be talking about a very important piece of software development. Last week you guys have learned Agile, right? Scrum framework. So Scrum is nothing but it's a methodology of develop a software. We do a bunch of things. We start with the sprint planning meeting and we plan the stories that we're going to do within the sprint, like 10, 15, 20. Um, however, whatever the number, right? Bunch of work, right? Small pieces of work. We identify them during the sprint planning meeting, and then the goal is to next 2 weeks just to get them developed, fully developed. But before we fully develop, you know, develop with quality, right? Leaving no defects behind. To do so, we have to design, right? Individual stories that how they will look like visually, and then once the design is done, then the developers start writing code, right? For each of those stories. Every story is a little part of the work, right? You understood that so far. So every user story is a little requirement. Developers needs to write a bunch of codes to develop that. And then testers needs to individually test each of the stories, right? Positive testing, negative testing, bunch of testing for each of the stories. And then this is how things get done. So developers write code, the testers will write test case for every story, and then that'll get developed, and then they'll get tested. And then each of them separately will be deployed to somewhere that we will take a look today, right? So this is the process. We piece them out, we chunk them out, and individually every story get develops separately, and then they combine together, and then they test together, and then we deploy them as a whole, as a module of work, right? Part as a part of the software. To do so, so no, so let's take a step back. So we have seen that the cultural piece of it in the last class, like agile, the benefits of being agile is like, of course, you chunk it out and you deploy once at a time, but it's also there are a lot of other benefits. It's iterational, right? If anything goes wrong, you just don't waste 5 months or 6 months or 7 months of time. You can rapidly go back and fix those, right? Because you're just wasting 2 weeks. Let's say everything goes wrong in a sprint, you're still wasting 2 weeks, not 6 months like waterfall. So that's one. Second is it's really motivational, meaning that you can fix your mistake, right? We do retrospective meeting at the end of the sprint. We have product owner. We can always ask questions. The product owner is part of the team. Unlike waterfall, that if we have a question, we have to wait for 2 weeks and go back to client. So there's a lot of benefits of agile, and those are the cultural thing that we constantly get better. We constantly get better to do what? We constantly get better to be more productive. That the mistake we have done in the last sprint, we're not going to do it right now, so that we can deliver more product, more code in a faster manner. So the point I'm trying to make is the whole point of being agile is being faster, right? We want to develop the software faster and frequently, not just faster. Like one sprint, we did so hard work and we did it so fast, and the next sprint, it's a mess. No, frequently, consistently faster. Think about it. This is a mindset, right? We need to keep our consistent speed, but at a faster rate, right? To do so, with agile, right, what you see in the cultural piece the last class, today we're going to talk about some important features and other methods of software development called continuous integration and continuous deployment. In short, it's called CI/CD. You're going to hear this a lot everywhere in your modern software development. So CI/CD doesn't contradict with Agile. It's just CI/CD complements Agile, right? They go together. So you have Agile, right? The process, Scrum, and then you have CI/CD practice, which is also often called DevOps. You're gonna hear that a lot too. DevOps engineering, right? DevOps is a new culture. It's a new engineering process that goes along with Agile, Scrum. So your team might have Scrum, Agile Scrum, plus DevOps practice. These two together, it completes the ecosystem of software development, of this faster delivery, frequently delivery, so on and so forth. But today we're going to look at what it is, how is the team is structured in DevOps environment, along with Agile, and what is the role of a tester, right? So we know the testers are part of Scrum team, and they have a very significant role to test the product. Unless they test the product, we can complete the development. So in this kind of DevOps environment, we're going to see how a tester fits in, right? So you're going to have questions and frequently ask the question. That's why I kind of turned my cam on today, so you can see me, my expressions and everything, because it's the most important fundamental we're going to discuss about software development today, DevOps. If you understand that and if you can explain this to them, oh my God, I mean, you are already passing all the parameters for interview. So it's really, really important. And I'm going to try to make it really, really easy for you in a layman terms. But still, if you have questions, just ask, stop me and ask it, right? This class is for us only, so no hesitation. All right. So, like I said, the whole thing called DevOps, but it's called CI/CD. But CI/CD stands for continuous integration and continuous deployment. Um, so if I go to the next slide, before I go to the next slide, I would bring today's agenda. Okay, so we have a bigger agenda for this today's class, and that is just don't unmute yourself and just stay there. Just if you want to talk, then unmute yourself and then go to mute right away. Um, so today's class 4, we're going to start with coding best practice. What really happens in a Scrum team? We need to understand, right? Yesterday we just saw a snap. Not yesterday, in the last class we've seen a snap of a Scrum, every Scrum in one slide. But what's really happened with the developers? How do they code? Individual story, what do they go through? Do they do any testing, um, or no, right? And then once they're done with the code, because we know developers code per story. Now, what if there are 5 stories? It's getting done by 5 different developers. That means every day we are writing code, separate codes for 5 different stories at a 5 different place. I mean, in their laptop. How do they get integrated? And then how do we do testing, right? How does CI/CD plays a role in there? So that's what we're going to discuss in detail. So today's class, it's a little bit of technical than last week, but we still kind of, learning the same thing. So coding best practice, that's one. Then what is a build? Build is something called, it's a package of code, right? Like I just said, 5 stories are getting developed into 5 different developers' local machine, and then they get integrated to get packaged up together. And that's what called a build. That's what we're going to learn today. Then CI/CD, continuous integration and continuous deployment, we're going to learn today. So be open for that. Then we're going to learn various environments setup within the organization. In order to achieve these deployment from one place to another, to do the testing, to do the development, and then various different kinds of testing, not just one. We also gonna look at the different kinds of test, right? It's not just one test in the industry. There's multiple different kinds of test. So in order to develop the product and go through all these different kinds of testing, we need more than one environment. So in an organization, we have multiple setups of environment. One is production, right? Production, we all know that Amazon.com, that's their production server, but they cannot play with that. That's their real code. The real end customer goes there. So what they have to do if they want to develop a new feature on Amazon, they need to just mimic like the production server, the production environment to a dev environment. That's where the developer is going to develop first, right? And then where the tester is going to test. into their development machine? No. So they need a separate environment for testing. So they're going to mimic a development environment to a testing environment. So like now I have dev, now I have test, and then production. So they gets developed in dev, and then move to testing, and then it goes to production. So this code movement we're going to learn today. That's very important, and that's what exactly is continuous deployment. Unless that this technical piece or engineering piece happens, then you wouldn't be, so you're writing code at some place, and then you're testing it in a different place, but someone has to move that right from that place to this place. So things like that. So you're going to learn that today. So and then also we're going to start learning software testing lifecycle. We have seen the software development lifecycle in Agile, but today we will see where software testing lifecycle begins within the software development lifecycle. It's also part of today's class. And then we can talk about various types of testing. All these, all the bigger picture that I'm going to show you today, I could have skipped it, right? I could have just kept you in the blind. You don't need to know these. These are the stuff for developers. These are the stuff for DevOps engineers. You as a tester, you should just write test case from a story and test it, automate it, and then you're done. I could have done that, but I'm not doing it. I'm just showing you the bigger dot, and then I'm showing you how you fit into that, right? Because you're part of that. We all work together to achieve the same goal, which is the better code with no defect. End of the day, I integrated better software, right? So, but these are the engineering piece of it, right? So, so I hope that after this class, you will already be an engineer. You'll feel like that you know so much about software engineering, at least software development. So that's going to give you a sense of accomplishment. Let's see, what question did you guys ask? Oh, thank you. You have asked a question, is there any sprint zero activities before the sprint start? Uh, I'll answer that question in a moment. Okay. So this is what we're going to cover today. So let's start with coding best practice, right? So let's say CI/CD is a process that we have that in place. Now what happened? So this is a game of three techies. That's what I put it in there, right? So who are these three techie people? I'm just it's a game of three techies. That's what I put in the title. So what's the game? The game, by saying game, I mean to say, uh, you don't see my screen, right? Hold on. All right, don't need a slideshow. This is good enough. By saying the game, I mean modern software development who are expert in Agile and CI/CD DevOps. These are the toppest, modernist software guys, software QA, right? So it's a game for techies. It's not a game for manual testers anymore. It's not a game for just blind developers. You have to know these ecosystem. You have to be able to work with these different people. So these three roles are very crucial. Developers, we all know who developers are by now. We got two kinds of developers, front-end developers and back-end developers. We also know that. So these guys are programmers. They are the one who's going to code by story. They're going to pick a story and code for it. And then we have DevOps engineers. That might be an also very interesting area where you want to take your career in the future. After working a couple of years as an automation engineer, a Q engineer, you might want to extend your career to DevOps. The reason I'm saying it as extension, because the salary goes up like 50K, right? Not 50, at least 40, 30, 40K, because the DevOps engineers are uh, basically their range is about 150, but they are the one who's managing all the CI/CD. So in order to make this whole process works, we need, with the developers, we need some DevOps engineers, and this is also your story, right? Look, excuse me, I put two developers for the front end, and then I have given two developers for the back end. So that's your story. You had four developers in your Scrum team, right? Two for front end, two for back end. Then we had two DevOps engineers, right? If you don't know what they do yet, don't worry about it. You will end of this class, but just make sure that you put this story in your brain that you had two DevOps engineers. And then what? Testers. But then what kind of testers? In order to achieve this CI/CD, this whole automated ecosystem, DevOps, you require to have automation testers, SDAT, right? We can call them SDAT. Yes, we can call them SDET slash automation tester. So in order to achieve these, industry is looking for more automation testers. So these are three technical roles. These guys are technical because they know how to write code. These guys are technical because they know how to create the infrastructure and manage the infrastructure. And these guys are technical because they are testers, just like you and me. We are testers. We're going to be testers, a tech Q engineer, but technical, meaning where we learn automation, programming, right? So these three roles, developers, DevOps engineers, and QA automation engineers, are required to work together to get the whole process automated and get the whole DevOps culture done. I'm sure you're gonna have question, but happy to answer that in a moment. But let's go to an actual, what do you call? Let's go to an actual slide here. Continuous integration. See, I have divided these two pieces called CI and CD. In order to really understand that, you need to divide them into two because they are two different things, right? In the industry, you're gonna see it says like that: CI/CD. CI stands for continuous integration. CD stands for continuous deployment. So, but CI/CD is basically the whole process. But today we're gonna understand that separately. First, we'll understand the CI piece of it. Then what do I mean by CI piece? Continuous integration. Then we'll understand the continuous deployment piece of it. But that's the whole automated process of your software development. Automated process. So let's come back here. Let's give us like 30 seconds for the breathing room because it's just gonna get technical. So if you look at the slide, in the slide we have a front-end developer, and a back-end developer. This is like day one, day two, and day three. Or it could be all day one, but we have three developers. When we kick off a sprint, after the sprint planning meeting, we have a bunch of stories in our Jira backlog, sprint backlog, right? That let's say 15 we brought in from product backlog to sprint backlog. 15 stories that we're going to do within this sprint right now. Now we have four developers, three developers, and we assign individually each story. So this front-end developer, let's say started working on story one. This front-end developer, developer number two, started working on story two. And this is a back-end story, right? So we are developing the front end and also we are developing the API and the back end. So this developer, let's say he's a back-end developer and he started working on per se story three. So now simultaneously, this developer is working on story one, this developer is working on story three, and this developer is working on story four. So simultaneously, we are having three stories to getting done. And when I say these developers are working on these three stories, what they're doing is basically think about it. What are they doing? They have asked all kinds of questions about these stories during the sprint planning meeting to the product owner to clear up their head and have the clear understanding about the stories. And the stories are written in Jira. And we know every story, if you want to read them, you can read them in Jira. It has a description and it has acceptance criterias. Acceptance criterias will tell you what is the story is all about and when this story will be accepted to the product owner. It's some sort of written criteria that you have. So definitely developer will go ahead and read those acceptance criteria in Jira first for each of them, right? This one will read this one, this developer will work on this one individually. So they'll fully understand what is the story is all about, what they have to develop. Based on their understanding, they will start writing code. They're writing code to develop the story. This developer is writing code to develop this story. This developer is doing this, right? But the coding. Now, when they're writing codes, what do I mean by it? They're writing where? They're writing into their laptop. Like I'm using my laptop, you're using your laptop. They're not writing together. They're writing individually. They're three different person. They're working on three different stories into their three different laptops. They're independently writing code. Now, this story might require 20 lines of code from developer one to develop the full feature, full functionality. Let's say this story. So first understand that he's writing code in his laptop, 20 lines for this story. This developers maybe story two maybe a little large, so he's writing 50 lines of code to complete the whole story two in his laptop. And then this developer is actually building the API, right? He's building the backend, the web service, the API communication. Maybe he needs to write more lines of codes. So his code is probably writing 100 lines of codes for this story. Now, once they're done writing code, this code is sitting into their own laptop, wherever they're writing. They could write in, they have a place, they have a tool called IDE, that's what they're writing. If I am writing something, I'm writing in this PowerPoint. So I need a software to write, right? They also have a software. I'm not getting in there, but they have coding software. Once you're going to start learning Selenium and Java code, you will also use the same software that they use. So every coding for the same, they have software, that's where they write the code. But the software is sitting in their own laptop. Now my question, when I write 5 lines of codes to, let's say I'm a developer and I'm writing 5 lines of codes to produce this story, do we test? Do I test? What do I do after I write my code? Do I give it to tester? No. So developers does some sort of test, and that's called unit test. Unit test means just that unit of code, just that first story. That's why it's called unit test. That's why we don't do it. Tester doesn't do it. Developers, does unit test. So into the best coding practice, developer will write code for unit of code for a story, because that's a little unit of the software. So they'll write a unit of code and they will do the unit test. The unit test covers only those codes. Now it's a white box testing. We call it white box testing, because they don't actually go to the application and test something. They actually test this code, meaning actually the physical code. If the code has any issues, spelling mistake, security vulnerabilities, static code analyses, all kinds of things. Later in the slide, I broke down into 5 major areas of testing. So first is the unit level, then functional, then non-functional, security, and UAT. These are the main 5 pillars of testing. So we are talking about at the unit level. So unit level testing done by the developer at the same time when they write the code. That before it comes to us. Okay. Again, what they do during the unit level testing, they do a lot of code static code analysis, static code review, meaning this developer one have written this code for story one. Now this developer might review that manually by his own eyes, just to, go over this code, this unit of code, to make sure that everything is okay. That's called code review, peer review, because all these developers are within the same team. So one can, review each other's code. That's part of the unit test. Just I've written something. I'm just asking you guys, one of you guys, like, hey, can you quickly review my code to make sure that everything is okay? Part of my unit test. So that's one strategy of doing unit test, right? That's called static code review or peer review, right? If you ever come across any questions or concern that how to do unit test, or do you know how to do unit test, or how unit test got done in your last company, just think of these examples that I'm giving you. So one developer bring another developers and do the code review. Now, question: if you are also a developer, let's say you are also a developer, but you are an automation engineer, you are here in the team. We have developers, and then we have you. You are not developer, but you are SDAT. So you also know how to write code, how to read code, and how coding works. Now the question is, can you do the code review for them? Well, the answer is yes. You can always say that in the interview, right? That even though I was, well, that's kind of the goal for SDAT anyway. So, the reason, the name of SDAT, it's called Software Development Engineer in Test, SDET. The reason they call software development engineer, because you are as good as the developer or close to the developer. You know how to code, but you don't develop. You test. And how you test? By writing automation test. That's code. So some of you might become so good at the end of this course, so you can actually mention it in the interview that you actively took a place took place on unit testing. How? You helped your developer to do the manual code review, that he wrote the code, every unit of the code, and you reviewed it manually. And you reviewed, looking for what? Looking for defects, like duplications of lines. Sometimes they do copy pasting, so there's a lot of duplications. um, sometime same word, maybe they'll have twice. Sometime you see an unassigned variable, like they declared a variable when they're writing code, but the variable was never assigned. That's a security risk. Maybe the hacker will find it extra line of code. So when you're writing a program and you write two extra line and never used it, that's unnecessary. That's a security issues. Your hacker might find it later and you use it for other purpose. So the code needs to be clean, right? So hacks happens every time. You don't want that. So you will be looking for all these manually. Like, hey, you declared a variable, you declared a class, you never used it. Things like that, right? Um, so that's kind of code review as part of the unit testing process. Apart from that, they also do some sort of static code analysis, security scanning, code scanning. So how do they scan? So they have a bunch of tools, automated tools. When they're writing this code in a software, that software has some plugins. Um, Utilizing that plugin, they can scan that code. So there's two types of unit testings are happening: by human eyes and then by softwares. And the software thing is called static code analysis, and the human piece called pair programming or pair review, pair code review, right? So a bunch of thing happens for this unit of code. And then once the developers and the peer review is done and everything is good, the static code review through the software scanning is done and it's good, then what did the developer do with this code, right? Have you thought? Are they gonna keep it in their own machine? Or are they gonna put this code in a place? Like what do we do? Let's say we are building different piece of a product to ship, and then we have to ship that piece of the code somewhere, right? And then this developer will start on the next available story. But where does this code go? So after unit test, they create a build, right? Codes are like samosas or some, pasties, right? It's individually. You cannot just keep them alone. You need a package. You need to put them in a package, right? Constantly new codes are coming. So let's say this build is a package. Where are you going to put code? So the build version is 1.1 because you are writing the story number 1. That's the first code you're writing. That's why it's build version 1.1. Once the developer is done writing and testing this first code, he's going to put this code into the package, and he's going to check in this code, check in this code check in. We call code check in where? To a remote code repository in the cloud. So every company has a repository for keeping the code. It's most probably in GitHub. GitHub is a company, but it's not complicated. It's We need a place to store anything, right? If I want to store my furnitures, if I'm going away from a couple of months, what do? We go to the Cube Smart, we rent a place, a 5 feet by 5 feet, and we dump all the furnitures there. That's a storage. If I want to store all my pens, what do? We get a pen holder. We can also store, books, magazines, other things on a table. So table in that case is a space. It's a storage. So why not for code? Code needs a storage, but that storage needs to be in a centralized location where everybody can check in. Developer 2 can check in, developer 1 can check in, developer 3 can check in. If we don't have a centralized code repository, then this developer is writing this code in his machine and is just going to stay there. And these two developer, it's developing story number 2. So these two are part of the story 1 and story 2 are part of the same application, different code. Now we need to make them, we need to integrate them at some point. So how that's going to happen? So that's why they need to put everything into one centralized repository. And this repository, the placeholder, the place, it's not in their machine, not in their laptop. It's somewhere else. It's like, think of it as like a Google Drive. Let's say we are writing on a same document that you are, right? Have you used that? I'm sure you have done. So I can create a Google document and I can give you access. You can all write on it. Whatever the updated version, that stays. It automatically saves the updates, right? If I've written an essay and you can update it, you can delete something, it'll be deleted for all. Something like that. So this is like in the drive, in the cloud. Now, obviously, we're talking about documents could be managed and version controlled in Google Drive, but this is not a document. These are coding. So to do the coding version controlling, there is a company called GitHub. There's a company called Stash. There's a company called Bitbucket. This provides the service of remote code management repositories. Your company will have one. Most likely your company will have GitHub. That's the most popular one. Let's see if I can bring in on the screen so you can see. That's a very popular company. The logo looks like this, little cat in there. Um, so it's a company that give you code management solution, code with GitHub Enterprise, right? GitHub.com. So it's a place where we keep the code, right? And where is it? It's in the cloud, in their server. So I can create an account with them and I can keep my codes in there from my laptop. So in our Transfotech Academy, we have service from them. So if I log in, I will be logged into my repository. Why is it? All right, let me find out the login. In the meantime, do you guys have any question? Or give me a thumbs up or thumbs down. Is it getting too hard for you to understand? Let me know.
No questions.
I have one question.
Yes, go ahead.
Is that like a story one, like the developer can write a code after same developer can test the code, or different developer test the code? Unit test about.
That developer, so unit test, okay, good question. So
Yeah.
under unit test, as you figured, under this unit test, there's a series of action happens. That developers, this developer who wrote the code, he's the one who's doing all sort of static code analysis, vulnerability scanning, security testing of the code by utilizing the same tool that he wrote the code with, right? That's one kind of actions of unit test. But then these developers is doing a peer review, helping this developer. These developers is also helping this developer to get that reviewed by a human eyes. That's a second set of actions. So both are happening. So for this story, for the unit test of these stories, both developers are performing the unit test, but different actions of unit test. So unit test is basically a series of actions to make sure this code is clear. Make sense?
Yeah, makes sense.
Good. So after that, it creates a build, and like I said, after creating a build, they put the code, check in the code into the remote repository. And I said this repository is in GitHub. So I'm just showing you my GitHub. I think I logged in. Let's see. Okay. So I go to github.com. I go to github.com and just give me a second. Okay. So I go to github.com. I'm not going to get into the details, but you can learn all of these in the future. And you see, I can create a space in here, repositories. These are all different jars. Transfotech TFT online coding clothing store, right? That's a project. So if I want to put all of my code in here, so I can just put all of my code into this repository in the GitHub. So that's a repository, and it has a master branch. And what I can do, a developer can do, they can put this code in there, in this space, in GitHub. Now this GitHub is in the cloud, into their company server. But I am putting my code in there, keeping it safe. Developers once doing it. Because I have a space into their server. It's just coming into this repository. Specifically, it has a name. So I want to create a new repository. Let's say for this batch, I can create a new repository. So it says here, right? Create repositories. So I can create a new space under the owner of Transfotech. Like that, every company has their own ownership. So if I create a space, let's say QA training batch February 21, a new space, new repository will be created. And then every code I will push, it will come here under this ownership of Transfotech Academy, right? So this is how you are centralizing your code. So the developers one is doing it Jubar, you're going on mute automatically. Okay. Um, excuse me. So this developer is checking code here. This developer, when the story number 2 is done, then this developer might ask this developer like, hey, code is done. Could you do the peer review? So he's gonna come and check this code. When it is done, then it goes to the same package. Remember this build one. Now this is the new version of the build. New version of the build 2.0 because this build just had this code for story one. Now, after this build goes in, these developers is writing code, new code. New code is being added to the package. So this build 2.0, this package has the new code and also has the old code the developer one has done. So this package contains the old code and the new code. Make sense? That's why it is built 2.0. And the next 3 developer will push in new code and will create a new build version 3.0. Very, very important for you to understand. And I think now you're clear what a build is. Build is a package. In that package, I'll have old code and new code. And this is your entire application package, right? Your application, let's say this is your software. The whole, let's say you are building Amazon. This is your whole Amazon. First, you build the home page. Then you added the search page. Now in this page, in this build, you have the code for home and search. And then the build 3 will have new code. And this developer will create the build 3 when it comes to developer 3, story number 3, same process, creates a new build, build number 3. Now this build will get check on to the code and this build will get tested. It hasn't even come to you yet because we are all in continuous integration piece, CI, and then we have a CD, continuous deployment. When a deployment happens, that's when you guys will have to test every build because this build has old code and new code. That is the next slide we're gonna go and understand that how when us we will be effective in doing testing into the continuous deployment cycle. But as far as this right process, do you have any question?
No questions.
You understood everything? Feel free to say no. It's it's a very
Yes.
complicated.
Yes, understand.
I have a question.
Sure.
The code check-in,
Right.
does it get checked each time or does it get checked after all the builds are done? Like after all of them are deposited in the, like as in build 1, 2, and 3, and then
Okay.
does it get checked in one shot, or do you have to check in each time and then check in again after all of them are
Okay, let's say this is also day 1. This is also day 1. That could be a scenario, right? All day 1. We're talking about day 1, right? We have developer, 3 developers. They all should work on the first day, right? So this developer will work on, they're working on separate tasks. They're not working on the same thing. Now, when this developer is writing code for the story 1, he's creating a build. After he's writing code, doing the unit test done, creating a build, a package. These developers needs to check in this code, this build, because this is in his laptop. This developer cannot check in this code because that's in his laptop. So each time each story is done, that gets separately pushed, separately build gets created by that developer, and that developers need to check in to the cloud, a remote repository, whatever you want to call it. This developer would do the same thing. Okay, so now this developer writing code separately, I told you, and this code is into his laptop. And then if he creates a build, right? How does that build will have this code? Because before this developer creates a build, he's gonna get the update from this repository, whatever this developer has pushed. Then he's gonna get the update from here, then creates build 2. That means his build 2 will have all the updates from build 1 and the new code that he have written. So that these developers will create build 2. Then he will push the build 2 again in here. So now this place has build 1 before. Now this place has build 2. Now this developer 3 will get the build 2 from here in his laptop. Then he will write new code. Then he'll do unit test, and then he'll create build 3. Now build 3 will have all the old code from build 2. So that's how it has build 3. All the code from build 2 and the new code that he has written. Then he will test it and do it. And then once everything is done, the build creation is successful. If there is any error, the build will fail, the package will fail. So they have all kinds of software, right, to do so, which is too technical for you. But eventually, if you want to choose a development career, you can learn this, but learn it at a high level. So if anything goes wrong, the build will fail. They won't be able to create a build. If everything is right, previous code, old code, no conflicts, then the build will get created. The new package will get created 3.0. And then he will check in the new package into this place for the next one. And this cycle continues.
Okay, thank you.
All right. Next question. No, just talk. Everybody needs to talk. If you don't understand, this is a very important piece of the thing. Fundamental knowledge of your modern software development. If you don't understand, let me know.
Very
Okay, I have a
quick,
question.
Oh,
Yes.
hold on. Okay,
Can I go?
go ahead.
No,
Go ahead.
you go next, Dubai. You already asked a question. Let's give Scene an opportunity, and then
Okay,
we'll come back to
right.
you.
Okay, no problem.
I just have to correct my pronunciation of my name is Sean.
It's Sean. All right, my bad, Sean.
But anyway, I'd like to ask a very quick question. Just actually, can you just more clarify? I think I didn't get that part much of humanized test and the other test part of that unit test.
Right. So the unit test, right? It's a series of action. It's not just one thing. So when this guy write code, this guy will come and check, right? Read the code. This guy, I mean, say humanize. I mean, to say this guy will come and read the code. Not any software will do it. This guy will use software to make sure this code is right, to scan it through the vulnerabilities, the duplication of variables, bunch of things that this guy will scan using the software. That's one. But this guy will come and also check by himself to see if the code is right. And that's also part of unit test. And we call it code review, static code review, or pair programming, or pair code review. So that's also part of unit test. But that's just so much of details. That's not your work, right? I'm just showing you the bigger picture, that how things get done, you should understand as a software developer or a software engineer. All right,
Thank
now
you. I got it.
cool, perfect. So go ahead, Jubair, now your turn.
Okay, hear me? Hello, hear me?
We can hear you, yes.
Okay. My question is like, when is the developer one is the complete the code? That mean after second developer get a code for the writing the second story and build up the second package. So that time will be create for user interface or not. Or another thing is the user interface. Another thing is that they who gonna do each other integration. Like first developer make something, and second developer make another thing. Who can make the together integration?
Yeah, that's coming next. So we'll just wait for that. Okay, that's the continuous deployment piece.
Okay, thank you.
Yeah, but that's a very important point.
Thank you.
He's saying that someone's writing the code for story 1, someone's writing code for story 2. I understand that everything goes in the same place, but who is integrating those two pieces of the code to build the entire application together? That's what happens in an integration environment. We of course we have to integrate those codes, because the code, the application, when I go to Amazon, right, it's an integrated software. I don't see story 1, story 2, a little piece here. It's just, you know, a full integrated software. I know I have some developers has written code for the homepage, some developer has written code for the card, some developers written code for the search module, but to the customer, it's an integrated software. To in order to get a software like that, so our code needs to be integrated at some point. So understand that, very important question. All these different pieces needs to be integrated together and then create a build at the end that has all the code in it integrated together, right? And then we need to do integration testing. We have one kind of testing, it's called integration testing. Why? Because we need to test software as an integrated codes. I think I'm coming there, so we'll just wait for that. In the meantime, a lot of people seems not to have not to ask questions. Are you guys shy, or you don't get it? Tell me what's going on.
No, I have one question. Then what is the backend developer works? Then is the first one and second one is the same work, and what is why that third one name is the backend developer?
Because we have two kinds of developers. Think about if you look into the first or second class,
Roman, yeah.
Roman, you'll know that we talked about, let's say I'm giving an example. Let's say we are building Amazon. So it's two things, right? You need to build this front end, the UI, user interface, right? This beautiful guy, which, we can see. But then somebody needs to build the API. So if I type pen, we know these the inputs, right? The
Mhm.
Amazon will send this request to the server, and then server will give us all the information about the pen as a response. But if I don't have APIs, the doors within this program, then this value will not be passing from here to the server. So who's going to create that API? Backend developer. So there's two kinds of developments going on, the front end and the back end, right? Somebody will create those APIs and web services. Is that a valid question, guys? I think Roman has asked, did you get it? Do you want to add any more question to it? Did you guys understand what I'm talking about here?
Yes.
Yes.
Okay. So the APIs needs to be built, and that's the task for the backend developer. So why there are two different developers? Because some developers are expert on building this front end, and these are called front end developer. If you want to be a front end developer, you have to learn certain things, right? You have to learn JavaScripts, HTML, everything that you see here. Everything that you see. Now, look, you guys are already in the engineering level. This is 1 month down the course. I feel like you guys are already in. From this point in life, you will just be an engineer. I don't know what you're going to become. I'm talking about majority. You might love being front-end developer. You might just start doing learning HTML and CSS and all these. Can you? Yes. Now tell me one company who doesn't have a front end. If you don't have front end, then how you sell, right? Every company will have front end. If you cannot do anything in life, you could be a front end developer, a tester. These two positions are open for you. Every company would need a front end. And so if you just learn a bunch of things, JavaScripts, CSS, and HTML, then you can easily become a front-end developer. So these developers are expert on front end, but they're not expert on, you know, building APIs, because that requires server side of the knowledge. That requires, how you're gonna right now, how you're gonna, I talked about the web service, the class 1 and class 2, that the XML file needs to be taken over and that file needs to carry this data to the server. So this developer has to have the server side of the knowledge. See, it's like different doctors. One doctor cannot do everything. So he's a different doctor. He's a developer, but he's a back-end developer, or we call him full stack developer sometimes. The high-end developers, right? Obviously, they make more money, but he's an expert guy. Thank you for your question. The what we are getting from this question, that there are different roles in your team, and they are developing different piece, the front end piece and the back end piece. And now let's go back to this example. The example I just gave you. Let's say this is this. The story one is about story one is story one. It's all about creating this search button. Okay, and within this search button, I am able to search. That's story one. After this guy checking this code, build the package. Within this package, if I open the build, then I will be able to go to this website and I'll see this button. I'll see this field, a white field, search button, where I will be able to type something. I'll be able to type anything, right? Now, if this backend developer will develop story number 3, and this story number 3 is actually the backend code for this, which is the API piece of this, which will connect with which will take this value to the server. And let's say that's not done yet. I'm here at the build 1. So at that moment of time, I will be able to type. But if I click in here, do you think am I gonna get anything back from the server or no?
No.
Good. No, of course not. So the API is not built yet. So who's building it? The
The back
backend
end.
developer. The backend developer is building it. Once that piece is done, and he creates a new build, and he needs to integrate the backend code for these, needs to integrate with the front end code. That's how code gets integrated. Now it's a complete system. Now this front end piece of the code works with the back end piece of the code. Okay. Now if you click pin, it bringing all the pin's information from the database, because the API is got hooked up, and this hooked up means being integrated. You see? So while so unit test is one kind of test, it's just that piece. But when this integration happens, then there could be a lot of things going wrong. So one thing is a front end testing, just front end testing. When this developer is okay, let's go to day 1. When this developer is checking in the code for this story 1, you can still do testing. What testing are you going to do? So you just have this. At that moment of time, you're going to do functional testing on these only. And what is that? You just, it's supposed to look Yellow, that's one test. So you're gonna match that. That could be a smoke test, that quick test. That, oh, this is yellow. Good. And then the second test you could do that. Hey, can I type something? Because I was supposed to type. This developer, if this developer has written this code properly, then I should be able to type anything in here. I should be able to type 1, 2, 3, 4, 5 numbers. Okay, so it worked. And then I should be able to type my name in here. Alphabets have worked. I should be able to type iPhone. That worked. All right, so I see all the iPhones. So I'm able to type. If there is any issue or defects, then you will see you are not able to type. You're not trying to, you're not able to type. And that's a defect immediately. Now, you're testing as well. You are testing when this code goes check in and the build gets check in. You are testing this build, right? In here. Developer also have done testing, which is unit test. But developer did not come to the website and test the looks of it. That's your job. You are more expert. They have done testing before it goes to the check-in. They have just tested the code itself. Like if I want to check out the code, if I want to see the code for these, especially for these field, you right click on it, go to inspect, and you see that 2 lines of code. They have tested these 2 lines of code only as part of their unit test. Wherever they have written these, they have tested it. You know, they have done unit test of this code. Now, when it checks in, it creates a build. You're gonna come and do the front end testing here, and here you're gonna see different level of functional and non-functional test, right? In here, you're gonna do a lot of, so unit test is done by the developer, and then you enter into the functional testing world. That's all you. Then after the functional testing world code, then the second task is non-functional testing world. Often we call non-functional testing, sometimes we call it a performance testing. Let me fix the typo here first. Okay, so unit testing is done, code goes to check-in, and then comes to functional testing world. In that functional testing, it is all your job. You do bunch of tests. You do smoke test. You do system test, positive test, negative test, boundary test, integration test. That's where I was coming. End-to-end test and regression test. That's all your work. So you fall into the functional testing world. Sometimes they will call you functional tester. So the question is, what is non-functional tester? Who are they? They are performance tester. Now, you most likely not going to be working into this performance testing world. These are two separate type of testing practice. It goes simultaneously. So who are performance engineer? They are performance testing expert. Again, you cannot be all the doctors. I mean, well, I have seen testers who are expert on both. In this course, you will also get some lectures and lessons on performance testing. But to be an you need to choose a side, whether you want to create a career here, you want to be a functional tester, an automation tester, or you want to be a performance tester. And there are more testings, security testers, UAT testers. The corporation will have separate departments, and each of these departments will have separate testers to fulfill all these testings. Does that make sense?
Yes,
Yes.
that
Yeah.
makes sense.
Hmm. You see the landscape? So when we call about QA, when we call about testing, it's not just one damn thing. It requires different knowledges. Let's say whoever is going to do the security test, that guy is completely different than you guys. This guy knows um, penetration testing, ethical hacking. That's kind of a post deployment testing. When do you do penetration testing? When you actually deploy the code. Basically, when this guy is deploying this code to the production, not this. Now that you're gonna learn continuous deployment later, you're gonna see the code goes from to the left to the right to all the way production, and then the penetration testing happens. Now we also teach cybersecurity. You've heard about in Transfotech we teach cybersecurity penetration testing. That's a huge role right there, but they're completely different than you. You are a functional tester. You work with the development team, and when they're developing every different story, you are coming up with the test cases for each of these stories. Your test case, why you are coming up with the test cases so that you can test each of the stories separately. Then you will test these integrated softwares. So you are functional tester. You work closely with the developer. These guys are penetration testers, a security expert. They know Linux, they know cloud, they know a bunch of hacking techniques. They know SQL injections. That's what we teach. Somebody wants to become a penetration tester, but they fit in a different area within the software development lifecycle, right? So penetration testers, ethical hackers are needed once you submit it to the production, right? Once you and developer done the code and you have done testing and it goes to the initial code repository, and from this initial code repository you go through the test environment, integration, staging, UAT. And why you go through different environments? Because you like to do these all different functional and non-functional tests and UAT test. So that's why you have these different environments. So once all of this done and it goes to production, that's when the ethical hackers and penetration testers kicks in, and they try to hack these production server to see whether it is really hackable. If it's hackable, then it's an issue. Well, everything is fine functional in the functional testing world, meaning that your developer has developed the right story. It works fine, right? What I mean, I'll give you a real example. Um, let's say you have developed this field, looks fine, also works fine. When I click enter, it works fine. That is functional piece. The functionality works. Yes, it works, but somehow it's really hackable. Meaning, instead of writing code in here, instead of writing pen in here, let's say I'm a hacker and I will write some code in here in this field. Okay, let's say I'll write some code, or I'll write some SQL injection, some sort of query that you'll learn. Select all from select all from some table, customers. Okay, see, now I'm not typing any pens, I'm trying to hack it. So I'm writing a bunch of codes, and you will learn what that means when you start learning SQL. So what I'm asking, that hey, give me all the information. Star means all. Give me all the information about all your customers. and I put enter, right? And my application is doesn't know how to handle it. It actually gave me all the customers' information in my browser from Amazon. Amazon is gone. I can do whatever. I can shut them down. I can shut down $600 billion company they're just because I was able to hack in. That's security testing. That is called ethical hacking, right? So company will hire these guys to do the testing here to make sure that there is no hacking, there's no vulnerabilities, there's no risk, there's no window open where hackers can sneak in. So you see, that's how the security test, not the security testing, I mean to say that's how the testing world has been divided. But that is out of our scope for this course. So what remains in our scope is the functional test, and not even the non-functional test. But we want to know what's non-functional test because you are an engineer. So the non-functional test is pretty much the performance test. Performance means how quickly my website works. Those kind of tests, load test, stress test, volume test, scalability test, that will be done by a different team. If they ever ask you like, have you done performance test? You should say, hey, I have helped my team, but I had a different team who has taken care of it. But I've actively helped them. We have worked together. And technically, I'm showing you the path. You should go ahead and start learning each of these different kinds of tests. YouTube it, Google it. There are many, but as long as you learn everything that's in here, like in this column at least, you're good to go. And just for knowing purposes, just learn what's a stress test, what's a load test, and performance test, and things like that. I'll definitely cover in my class as well, at least one class explaining all of these. But the learning has no ending, right? You have to learn, at least you know that your thing is there. So you need to learn this by your heart, and this just for your knowledge. And this you don't need to really learn, but if you can, what it is at least is better. And then UAT also, if you can know what it is better. Okay, any question?
No questions.
So the next assignment would be definitely that I'll ask you to learn all these. I'll give you a link, and you don't need a link. Just go to Google and type end-to-end test. You'll see a bunch of informations, and you'll learn. You type positive test, you'll type functional test. You'll see all these, but I'll give you a link that I like. Guru 99. I'll give you that. But so you'll learn all these testing. That's the assignments for next week. But let's go back to the class. Do you guys need a break for 5 minutes? Or you guys are okay?
I'm okay.
Let's do 5 minutes.
What about others? I have a lot of people who doesn't like to talk to me. That's bad.
Give the 5 minutes for.
Okay. All right, guys. I hope you guys are back.
Yep.
All right, cool.
I'm back.
Okay. Few others. Just say you are back.
I am back.
All right, perfect.
Yes,
I'm here.
I'm back.
All right, cool, cool. Thank you, thank you. All
I have
right.
I have one question.
Yeah, go ahead.
UI testing, part of functional testing.
UI testing means the front end testing, but I was just showing you, right? UI means user interface. UI means this UI, user
Okay.
interface. And then you have backend, API. There's two things, UI and API, right? User interface and application programming interface. UI means this, and API means the piece that carries data from server.
Okay. That's mean this is part of functional testing, right?
UI is part of functional test,
Yeah.
yes.
Okay. Thank you.
I'm back.
Rashmi, thank you. All right, let's start. Now, we'll see the remaining piece of our DevOps knowledge. So let's say you understand this process, I know, right? It's the same process for each story for different developers. So for example, I'll just take the last one, story 3. When story 3 getting developed, this developer is doing it, right, same process, but he's creating build 3. Now when he's creating build 3, he's checking in build 3 to a repository. But that code repository it belongs to an environment, which is a dev environment. Like I said, remember that we have QA, we have dev, we have production. Obviously, he's not putting this code into the production repositories, right? For example, you can take an example for Transfotech. So this is Transfotech website called transfotechacademy.com. If we go there, it's hitting the production server. This is our productions information, and it's too slow. See, so it's slow performing. So there has to be some performance testing done. Uh, but it's hitting our production server. All the data that's getting loaded right now, it's coming from the production server. Okay. Now my question is, when this build 3 is getting pushed, is it getting pushed in the production? Of course not. This is my production, and my production code would be this coding. This is actually right now live to the customer. So these codes are also in a repository that's in the production repository. So the point I'm making is this repository belongs to an environment, but this one is not production. The production also has an environment. To understand that, we're going to go to the CD piece, continuous deployment piece. So this is our dev environment. Let's think of is this repository belongs to the dev environment that all the developers initially checks the code in. So that's that. Cloud code repo dev. So this is my dev environment repository. So in an environment, right, we have a bunch of things. First, we'll have a remote code repository where we put the codes, build, and then we have a bunch of servers, right? So as you can see, these are all environments. I've designed them here for your better understanding. So it has 2 servers, and this something like cloud, that's your repository, code repository. different repositories, right? Like I said, in the GitHub, you can create different repositories. This is your dev, this is your test repository, test environment, this is your integration environment, separate repositories, staging environment, separate repositories, UAT has a separate repositories, and then production, right? If you want to access any of these environment, if you want to go to production, where do you go? www.transfotechacademy.com. Just like this. This is my production. If I want to access and test, I go to the URL of the environment. Now, if you go to Transfotech Academy, it'll take you to the production. But if I want to go to test, then I have a separate environment, test.transfotechacademy.com. Now, this is not exposed to the public. Amazon is not exposing their test environment to you. They're only exposing the production to you, but they have a test environment which you want to access. You go to test.amazon.com. So in our case, it's dev.transfotechacademy.com to access the dev. Sorry, it's the dev here, the first one. And the second one is the test, this one. And then if you want to access the integration environment, then you have www.intintegration.transfotechacademy.com. So each of these environments you can access by going to this different URL. Each of these environments are a little different, right? But they are the same thing, same code. Any of these website, any of these URL that you visit, you should see it looks same because it has the same code. Initially, it goes to the dev environment, and then it should be moved to test, integration, staging, UAT, production. And we're going to talk about why the code needs to be moved and deployed to, different environments. But first, understand what is these environments are. In each of these environments, you can see two servers. It's actually three servers are there. They're different servers. One is called app server. Another one is called web server. Things like that, right? There are multiple servers. Servers are computers, right? And then these servers are tied up to a repository. The code is always sitting in a remote repository, but there are app servers and web servers and things like that. So all these 3-4 different things build up an environment. But that's such a deep, details, technical details. What's important for you that you want to go to an environment to test, you have separate URLs. If you join a project and they ask you to do some testing in integration environment, you need to know this URL for the integration environment. They will tell you. If you don't know, you have a stand-up meeting. Ask it to your developer, ask it to your, everybody should have these integration environments and all these environments, links and everything. And then in a big project, they produce a lot of documentations, wikis, wiki pages, Confluence pages. So it should be there. This information should be somewhere. If you can find it, ask. Now, let's take a step back. Like I said, that this repository is the dev repository. It belongs to the dev environment. So the developer pushed the code to dev environment first. The build, actually, not the piece of code, the whole build to the dev environment. Then the code comes to dev environment. And here, after it comes to the dev environment, we do smoke test. We do that, right? So now the question is, what's the smoke test? Remember, unit happens before the code comes to dev. The build, individually developers does that. When it comes to after, builds get deployed to dev, after build gets deployed to the dev environment, we start doing functional tests. So functional testing is a series of testing again. First, we do smoke test, right? So we do smoke test here. most probably. And I say most probably, don't get confused, but every company is different. Uh, you just need to understand the fundamental, and if they're doing things differently, you'll be able to figure it out once you go there. But point is, I just got a new build, and first test we do is smoke test, and it's one kind of functional test. The question is, what is smoke test? If you read the definition of smoke test, you'll see it's a kind of test that is quick, that doesn't take a lot of time. I just want to quickly test the major functionalities of my application. That is smoke test, right? After I get a new build released here or deployed here, if it's Transfotech, then I'm just gonna see the major functionalities quickly. I'm not going into details. I'm just checking if I click this button, does it work? Okay, yeah, it gives me a book an appointment, um, appointment booking window. Now I'm not getting into details that, oh, let me then book an appointment and send a message and then go check, in my email whether I got an email or not. That's integration test or functional test later. I'm not getting into detail. I just got a new build, so I'm just going to test quickly the major functionalities, right? To make sure that nothing broke. So I'm going to click on this button. See, it broke. Look, nothing came. That's a defect right there. So we have a defect in our system. See, this is what exactly happens when you do smoke test. So this is smoke test, just the quick, rapid test, and without having any test case. Meaning you don't have to write the deep test cases. You don't have to write those steps. You just quickly test the major functionalities first. Okay, like, okay, this is good. The links are good. You're probably clicking on all these link and checking it is going to the next page or not, and then coming back will be like, okay, and play the video. Okay, that's in the home page. So play the video. You're able to play. Okay, courses we offer. What if I click in this link? Does it go to the next page? Let's see. Yeah, it looks like it's going to the next page. Yeah, so next page is good. Can I go back? Or can I go back? I can go back. Things like that. These are smoke tests, quick tests. I think you got the point. So that's the first test we do. Then what happened? So by doing this smoke test, we're making sure that once the developer creates the build, the new build, that build has all the old code, and that build gets deployed in here. By doing a smoke test quickly, first we're making sure that all of our major functionalities are working. Nothing's broke. Well, technically, if I go deep down, and we'll see some defects and everything, but at least my major functionalities are there. Nothing significantly broke. Okay, so that's the value of doing smoke test. It's quick, time efficient, and I can quickly check my major functionality working. Then what? Then, like I said, we have these different environments to do different testing, right? These environments are there for doing different testing. So that's why it's called continuous deployment. So the code is tested here, smoke tested here. Now it needs to get continuously deployed to one other environment so that I can do other testing as well. So this code needs to get deployed to test environment. Now, what do I actually mean by deployment? Meaning, I told you that there is a repository. This is the dev environment where all the devs are putting code, so that there's a repository to this environment. They're putting code in the dev environment, and this code is actually the build, the update, the latest build has all the code. Now, this test environment also has a repository in the GitHub, a different repository. I shown you, right? Okay, so showing you like if you're using GitHub, you can have multiple repositories here, one for dev, one for test, one for integration, one for staging, one for production. These are separate compartments. So every one of these repositories is tied up with the different environments here, right? There's a repository, there's a repository, there's a repository, repository tied up with the servers, creates the environment. So from the whole build, initially sitting in the dev, from this repository, the whole build needs to move to the test environments repository. And that is called build deployment. So build, new build comes from dev to the test environment. And then when it comes to the test environment, you build the test environment. So that means that now if you go to this website, the whole environment gets built with this code when it comes here, and you will be able to see the same website as the production environment. The codes are here, or whatever the latest build will have, you will be able to see that much. Now, when it comes to the test environment, you go to this test environment and you do what? This is where you do the functional test. All right, that's why it's called test environment. Now, functional test is, like I said, you guys will be a functional tester. So in next few classes, at least the next class, we will talk about how to do functional test. All these classes, all these things that we've discussed today to just show you that this is where you are the most effective. This is your environments. This is mainly for the developers, as you saw in the earlier slide. But this is you. This is where you're going to do all the testing, right? Testers. These are there for testers. Then finally, when all this testing pass, then it will be moved to production. So until that happens, the build will constantly get deployed from test to integration. And this is where you're going to do integration test. And then it'll be moved to staging. Mainly staging is an environment. This is where you like to do the performance test. But every time the builds get deployed from one to another, you see regression test, regression test, regression test, regression test. Even in production, after the build goes to production, you do regression test. So what is this regression test? Regression test is retesting everything once again, simple as it is. Meaning when the builds gets here from dev in here, if we go with this example, let's take a step back. I think we're moving too fast. Let's take a step back. Sometimes I forget that you guys are newcomers, right? All right, let's take a step back. Look, while this guy is developing the code, meaning he's day one, let's say day one or day two, whatever, he's writing the code, literally typing and writing code to develop this. And after this, he's going to do unit test, he's going to do build, he'll check in. He's got work to do. It's going to take time, right? 8 hours, 10 hours per story. You are a tester. What you are doing at that time? That kind of starts the question also that remember STLC, software testing lifecycle. So this is software development lifecycle. You start with the sprint planning meeting, developer understand the requirement, and then developers read it. They start coding. They are doing unit tests. It's all part of development. But when does software testing lifecycle start? Like, is it start for day one? Then software testing lifecycle has to do with you because you are the tester. So what do you do when the developer is coding? Any idea? Like day one, they
Develop test cases.
develop test cases for each of these stories. Day one, This guy is coding for story 1. You are preparing tests for story 1. You're preparing tests for story 2. You're preparing tests for story 3. Now, what kind of tests are they? Functional tests, positive tests, negative tests. These are the techniques to do functional tests. Now, if I want to take a step further in deep, how you do it, you're going to ask me, right? Because you guys going to have to do it when you go to the job. You go to Jira, read the story, read the acceptance criterias, and then for each of the acceptance criterias, you write a test, positive and negative, right? But you are just testing this story. You're not testing them integratedly. You're testing them separately. You're writing a test for these, but not at the code level, but at the UI level, user interface level. Somebody asked me about user interface testing, but at this level, that you're going to check this box at the UI level, you are writing a test to test at the UI level. That's a functional test you are preparing. So the software development lifecycle, software testing lifecycle, in an agile environment, it goes in parallel, right? So I can say SDLC and STLC happens in parallel. When software development starts, software testing also starts by the software testers. So and now if anybody is asking you any weird question, you should be able to answer it from your concept. Don't answer from the books or anything. I see that people have hiccups on understanding of when does STLC starts, when does SDLC starts. It's all a Scrum, same process for us, right? So when Scrum starts, STLC starts. How this sprint planning meeting, developers are understanding the requirements, testers are understanding the requirement stories as well. That's when the STLC starts. You are testing it. You started the process. So make sure you're clear, right? So then while developers are writing the no, I'm saying that let's say that you're writing test cases for each of these stories. But one thing you need to note, you're writing these test cases. I don't know if you all know how to write test case yet. Maybe not. I haven't shown you yet. But test cases are nothing but some sort of preparation for the test. You're writing the steps of what you're going to do, what you're going to test, what you're going to look for. When would you know the test pass? When would you know the test fail? So you're writing those steps in a document. It could be a Word document, could be Excel. If you're using Jira, then you're going to write in Jira, right? Jira is there, so we will write on Jira basically to manage all of these artifacts for testing. So that's test cases. But why you are writing test case? So that when it comes to the test environment, you can test it. You can do all the functional tests. Now, you see the process of SDLC. You are preparing the test first. You are preparing the test while development is going on. Then once the code, the build, get deployed to test environment, that's when you're going to execute those test cases. And what does execution means? Actually, you're going to do the testing hands-on. So if I'm doing the testing here, when I was writing the test case, I would say go to Amazon. You will see a box, looks yellow, search box. And step number 2, type in. Step number 3, click enter. Step number 4, you'll be able to do all the pens but nothing else. If you see that, then your test will pass. I would write it when I write the test case. When the code comes here, deployed, I will see, oh, I have a test case. Now I need to execute them. I need to follow the steps I need to match the result, whether it is matching with the expected results or not. Same thing. Now I've already documented the steps in a test case. Now I can give this to anybody. If I'm the lead, I can give you one of you, like, hey, execute this. See the value of writing test case? Now anybody can execute that. So that's my test number one. So like that, for each of these story, you're gonna have number of functional test cases. Why number? Why not just one by one? Because one story might have more than one acceptance criteria. For each of the acceptance criteria in the story, you need to write one test case. But then for each of the acceptance criteria in a story, you need to write a positive test and a negative test. You need to test the positive side and the negative side. Sometimes negative testing is also called alternate flow, especially in the government. They don't want to use the word called negative. I don't know why, it's just weird. But it's called alternate path scenarios. So the positive scenarios and the negative scenarios. So therefore, one story can lead to have you multiple test cases. So now let's say for if we take these three stories as an example, we're gonna end up having 9 to 10 different test cases. And you have prepared them while the development is going on. When it comes here, obviously you will know because they will tell you. That's what the stand-up meeting is there for. And in the stand-up meeting, you have the DevOps engineers also, most likely. Now, who are DevOps engineers? The person who manages these deployments. Someone has to move, right? Someone has to move. The developers don't move. Developers, it's that's why I separated it. Continuous integration. They are constantly integrating new code. They're coders. They're writing code for stories, and that is getting integrated into new builds. New builds gets pushed up into their environment, which is here. But who moves it to different environments so that we can test them and finally move it to production? Also, someone needs to move it to production. That's why we need DevOps and engineers. That's why it's development plus operation. This is operation, movement, deployment, movement, operation, right? That's how the word came up called DevOps. There's a reason. It means something. So now you see, said we need developers and we need a proper environment set up like that. And then we need DevOps engineers to manage and maintain because anything could go wrong. And then we need testers because the code we are moving into this test environment integration afterward to do testing. So here you're going to do functional test, which you already have written test cases for. Now you are executing. You're just doing functional tests, right? So that's easy. I've written the test cases while developers were developing. Now I'm going to just execute the functional test cases. And if everything pass, I'm going to report. Maybe the DevOps engineers can move it to integration environment. And in this repository, codes get integrated. This is the integration environment. All the different code comes and integrates here. Just understand. Don't think too deep, right? Just understand the concept. So here we are doing functional tests, every story individually. In this integration environment, we're going to integrate the front end and the back end, let's say, right? Now we are integrating the API piece of these modules. Then we have to do integration test. So we cannot just go there and type and be like, oh yeah, I'm able to type, it worked. Now I have to do type a product, look search for a product, and then go validate each of them, right? Now two modules got integrated. This module, which is search, and then the API, and then later sprint, we're gonna create more modules to integrate, right? Let's say now the third sprint, we're gonna integrate these modules, right? The product module, and we're gonna integrate this cart module. So that means that now if I click add it to cart, it's gonna add it to my cart, right? Slowly we are integrating more modules, more code to the um, integration environment, right? This is where you do integration test. So do the integration test, you go to this int.transfotechacademy.com, whatever the URL, the URL will be changed, and this is where you do the integration test. The next module you'll do proceed to checkout, right? This is a new module. So different modules will come and slowly get integrated here, and here you do integration test. So integration test is also sort of functional test. If you see in this chart, it's also functional test. Smoke, system, positive, negative, I've talked about it. Boundary, you'll see. Integration test is also some sort of functional test, but it's long. It's not just the little piece of that one story testing. It's multiple stories that combine together, right? And it's testing a flow, entire software from A to Z as we are slowly building. So that's integration test. Okay, and it's mainly done through the front end because I haven't gone to the back end yet, right? It's mainly through the front end, and there is one kind of test we call um, end-to-end test. And to do these, you need to actually go to the server and do it. And that's the next class. I'm going to cover all these different type of tests in details. You learn that, but this come back right now. What we were saying that test environment, right? This is where we do functional. And then after we're done the functional, executing the functional test cases, it goes to integration. And goes means, again, the DevOps teams deploys to the integration environment. And when it comes to the integration environment, we're doing integration test. That means you also have to write test cases for integration test. So you cannot just write in a sprint. You cannot just write the functional test. You need to keep in mind that as story 1 is getting developed, as story 2 is getting developed, as story 3 is getting developed, you also have to write test cases that combines story 1, 2, and 3 to your integration test. Because you know that at some point, this build will get deployed to a integration environment, and this is where you need to test the entire flow. You need to combine all these stories, all these pieces of the different functionalities together and test it as a group, right? So you need to write those test cases in the sprint. That's one. So if you have those test cases written previously, when the code comes here, then you're just executing them. You're just performing those tests. That's done. Okay, easy also, maybe not hard. But then what's regression test? What do I mean by regression test here? And then when I'm done with these and it goes to next staging environment where my performance test is getting done, but I'm also doing regression test. When it's going to UAT, I'm also doing regression test. Now, what is this regression test and why it is every time we need to do it and why it is so important? Because look, when the code comes here, right? You have done smoke test, but when the code comes here, you've done functional test, right? But when the integration happens, these piece of the code you just tested isolatedly, when one functionality, each, just one story or two stories in an environment. But when that package gets built into an integration environment, that means new code comes into the integration environment. That means everything, every testing that you have done in here, all the functional tests, let's say you have like 10 stories, 10 test cases here, all the test cases that you'll be executed here, you have to execute once again in here, along with the new integration test. So everything that you've executed here, you need to re-execute it here to make sure when the new code came in, the old test cases are still passing, meaning that no new defect has been introduced by the developer. Similarly, when it goes here, you need to re-execute everything again that you've executed here in here to make sure while you're doing performance test, all the old functionality didn't affect after the deployment. So every time code goes to a new environment, you need to retest everything once again. Think about it, how tough this is. Is it possible? Let's say you have 200 test cases, okay, for example, and you have continuous integration environment or DevOps culture, where typically what happens, day one, developer picks a story, write code, do unit test, code check in. The moment it goes there, you do the smoke test, right? CDPs comes in, you do the smoke test, and it goes to the functional test, and you have 200 test cases by that time. Let's say we're talking about sprint 11 today. You have 200 test cases already. Now, in here, you have new test cases for this sprint 11. You have added 10 new test cases. Now you have 210. You've executed everything. Now, when it comes here, can you execute everything again? Do you have time? Do you have testers to execute, keep executing 200, 300 test cases again and again and again and again? Every time the code goes, it's because it's happening so fast. I have 3 developers. It's not just 200. I have 3 developers. So one developer is constantly pushing code. The second developer is right behind him pushing code. That code is going to go through the same process. So these code developers two code, these build two will go through the same process. The build three will go through the same process every day or in every sprint, however you want to say it. It doesn't matter how fast. I want fast. I want as fast as possible. To get this done, meaning every time the developer creates a new build and the build needs to move from this until the production, and all these tests needs to be re-executed once again. And that's regression test, by the way. Retesting everything once again to make sure that newly introduced code in a build didn't affect the old code. So when you tested build number one comes here, and then here, it's production. Now when your build two and the build two comes here and here, you need to retest again because build two has new code. Developer two has checked in new code. That might affect the old code. You can never tell. You cannot say like, oh, I have tested everything during build one, and why am I going to have to test all of these again? That's the process. Because build two has new code introduced with the new build two code. I'm sorry, build two has new code that's got um, integrated with the build one's code. Now there is no way for you to know that this new code might work fine, but that might affect old code of build one. Similarly, when build three comes, build four comes, build five comes, how many times, how often developer creates a build? Often. In some company, they're so fast and they have all this deployment is an automated deployment happens. The DevOps engineers creates a process that the deployments happens automatically also. In that environment, they creates multiple builds a day. So in that case, how does our role of a tester look like in DevOps environment to you? We don't need manual testers. We can afford to have manual testers because when the DevOps kicks off, it comes here. If we're doing manually, good, fine. Well, I have 10 test cases, maybe 200 test cases, maybe I have like 10 testers. Let's get them 10 each. Let's get them done. 200 test cases, build one, going here. But then, hey, 6 hours later, there's build two. Now, how am I going to do again? I'm going to execute 200. All right, let's say I pushed myself, I've done it, build two. But then 6 hours later, build three is coming. Okay, fine. I will do it. Fine. I have testers. But then when it comes to the integration environment, now I have to do 200 plus 200 plus 200 at a different time. It's not possible. It's the only way it's possible if I automate my test. In order to make this whole thing come true, the only way it's going to be possible if I automate my test. That's why I put this slide is the DevOps is a game for techies. It's for you have developers, you have DevOps engineers, and the testers are all automated testers. Meaning that when you are writing the test cases for these each stories, you also automating them at the same time using Selenium, Appium, whatever the tool you're gonna learn. You're automating them. The benefit when it comes here, now you don't have to manually test. When it comes here, same test, it's automated. Now you can just run them. And that's your regression test. So the automation is important for your regression test. And what is regression test? Retesting everything once again to make sure the newly introduced build, the newly introduced code did not break any old functionalities. So every time there is a defect, understand these also. Let's say let's say we've got a new build in the dev, right? Like just like the Transfotech. Let's say this is a new build, just came in, and instead of going production, we're gonna go to the dev, right? Or the test. And we found a defect like this. Like we're clicking in here and it's not working. It's broke. And you caught this defect and you're gonna report this defect in Jira. That's also your job, right? To write a defect. So you're gonna write a defect in Jira, and the developer has found this defect on build what? Maybe build 3. So you're going to mention it that I found this defect on build 3, right? And maybe you have caught, hear me out, maybe you have caught this defect here at UAT testing or here at integration testing level. When it came to here, then you found this defect on build 3. So you're going to mention in the Jira that I've caught this defect in integration environment and on build 3. What do you think developers are going to do with this defect? Or what do you think they're supposed to do? They would read your defects, understand where it is coming from, and then fix it and create a new build. Because when they're fixing it, meaning they'll go to build 3, and build 3 is a package of code, they'll open that package and then they will take out the defective code, what's producing the defects, or they will add more code to make it fix. However it is, you are adding, you're opening the tested build, you're adding more codes into it, or you're adding more stuff into it. And then what? Creates a new build, and that's going to be build number 4. Similarly, checks into the dev, it comes back to you, you do a smoke test again, and then it comes to test environment, and you do that defect testing, that exactly that test case that this feature, right? After defect fix, you come here and you test these scenario that whether it is really fixed or not, right? That's what you test in the test environment. When it comes here, you're going back because the defect's been fixed and developer gave you a new build. Now you go back and check the defects being fixed here or not. But then when it comes to integration, you gotta retest once again everything, cause that developer had to open the package and put some new code, and that code just the defects got fixed. The defects got fixed because when it came here, you have independently tested that defect, that whether it's fixed or not, and you found this is fixed. Is that all? No, because that might cause other issues because developer has opened that package. So that defects might got fixed, but developer might created some other issues somewhere else. So for us, that's the only way to make sure that he didn't create an issue if I retest everything else here again. So then only we'll know that, oh, that defect's fixed, everything else also passing. So that means no new issues has been introduced. So see how complicated it is the testing process. That's why we need a lot of testers. That's why we need expert testers. Now the problem is, I understand all of these, and I know that you guys understood too. Problem is that happens so fast. I mean, now I'm telling you that the build happen every day, multiple builds happen every day, maybe in a faster team. So how do we cope up without automation test? There's no way. That's why we need this test while we are writing these test cases in a sprint. We are also automating them. And even better, if all of my testers, if all of you guys know automation testing, better. You're writing test case, you're testing, you're automating. So once you're automated, then once you're automated within the sprint, well, the developers are developing, then I don't need to worry about that later. It just becomes automatically, it becomes part of my regression test because it's automated. Now, when it comes here, you're doing automated smoke test. When it comes here, you're testing manually the current functionalities, right? All the test cases that you've written here, you're doing manually. But when it comes here, now everything is automated. When it comes here, this regression, it's all automated. So I'm not actually doing the old work. The old work, the regression purposes, I've already automated once. Now I'm just gonna keep executing them. That's the benefit. Now, another benefit, when all of these different testing after all of these different filtration, when I feel like that the UAT testing has been passed, and UAT is a manual testing process. That's why it's out of your scope. Maybe not. Maybe you can get a job as a UAT tester. But UAT is a manual process. Why? Because we don't want to just believe in automation. Because UAT is the last testing before my code goes to actual production. So I want some sort of human. I've done all this automation test, all integration test before. I've done performance, functional. It's good. I like it. But at least before it goes to production, I want a human to test it just for my satisfaction. Let's say that I just want to believe machines makes mistake, or humans makes mistake who operates machine. I want a physical human to test it, and that's UAT. So that's why we bring end customers from the market into our office, and we give them the product to test. If it's Amazon, we give them a UAT version of the Amazon. We're gonna tell them, hey buddy, our Transfotech. We're gonna say, hey, this is the build. Everything has been tested before, but you test it on your eyes. You're a human. You do whatever you want to do. Make sure that it meets the user requirement. Means that it's fun to use. It's easy to use. As a user, you do the testing. That's why it's called user acceptance testing, and stands for UAT. where we bring a user and they test the software there to see whether they're accepting it or not as a user. They don't care about functional tests. They don't care about positive. They don't care negative. They don't care about integration, any of these. They will test it as a user. They're human. They'll test it as a user. They'll do stupid things. They'll just click like 5 times and see if it breaks. So that's why it is a last sort of filtration. After that, it goes to production. That's the whole testing process. Now, I want this to happen every day. I need a couple of things. I need a process where these deployments from moving code from one server to another, one repositories to another, happens automatically, right? I can't rely on my DevOps engineers to do it manually. I can't rely on my manual testers to do the manual testing. Let's say I have hired all these automation engineers to do the testing. So they will do manually and automation automatically. They'll write automation tests. But the problem remains with the deployment. So how can I also automate that deployment? Because my tests are automated. So if the deployments also get automated, then everything is automated. Then there's no human. There's just then what happens when the developers what happened to my mouse? All right. When the developers write some code, do the unit test, and check in, okay? Check into the dev environment, boom. Then when the code comes to the dev environment, automation test will kick off. Who will kick that off? Some sort of tool, if we can think of. If we can think of a tool, if we can create a tool to guide that, if we can tell the tool, the hey tool, whenever there's a new build comes into the dev, I'm so okay. Hold on, I don't know, something's wrong with my mic mouse, but it's got fixed now. So if I can tell my tool right here that hey tool, whenever there is a new build, let's say for say this build, or this build, or this build, whenever there is a build gets checked into the server, you know what you should do first? Smoke test. Do execute all the automated smoke tests. Here is my smoke test. You also need to tell the tool that here's my smoke test. Someplace there where the tool can get it and execute it for you. Let's think about I'm dreaming. I'm just like think about a fancy world, right? Uh, how good that'd be. It'd be like awesome. Okay, the build came in, the tool sensed it like a sensor, right? And executed all the automated smoke test, and all the automated smoke test passed. Then I'm saying, hey tool, if all the smoke tests passed, then only you will deploy it to this location, this repository. The repository has a name, right? This is a test environment repository. Then I'm giving the location. I'm saying, hey, deposit it in, deploy it in here. And then I'm also saying, hey tool, when it is a successful deployment here, then execute all my automated functional test. And here's the location of the repository where I keep all the automated code for doing the functional test. So execute that. And then this cycle continues. So I'm saying when all the tests pass, then only deploy it to this repository. And then execute all automated regression test. Here's the location where you're going to find all the code for regression test. So then the tool will do it for me, right? And then it'll go here. It's like Aladdin, right? The if you have seen the Aladdin, some of you might have. That you're telling, hey, do this, and it'll do that for you. Um, so then it goes to performance. The same process. These deployments is automatically happening by the tool. How good that it be until it goes to the UAT, these whole deployments and test execution is happening automatically, and then it go to the UAT. Then you are bringing your own end user customers, because UAT is a manual thing, it's not automation. Or you could also automate UAT if you like to, right? Why can't you? Yes, you can, but it's normally corporations are doing manually. But then once the UAT pass, then if you want, you can also ask that same tool to put the code into production. Now I told you that I'm dreaming, right? Is that even true? Yes, it is. If that's true, then think about it. The moment any developer will check in some code for any story, after that, everything happens automatically through a tool. Deployments to various different servers, and before deployments, automated test, make sure that it's done, the tests are passing, and then it's getting deployed. That also happens automatically until it goes to the production. That means we are automating all this process by the DevOps culture, DevOps practice, by implementing a CI/CD environment, a continuous integration happening. Developers are continuously integrating new code, and CD meaning continuous deployments happening because it's automated. So CI and CD, continuous integration and continuous deployments. And excuse me, and this CI/CD is DevOps. Altogether, this whole cultural piece, in order to bring this whole cultural piece, we have three three types of engineers: developers, DevOps engineers, and the SDAT level of automation test engineers. These three people work together to create a process called DevOps. But if we break down this DevOps process, we see two things: continuous integrations are happening and the continuous deployment is happening. Our work as a software QA, automation, SDAT engineer, our work ties into more like into continuous deployment ecosystem, because we need to automate the test, so these automated tests could be executed part of the automated deployment, so that we can create an entire automation ecosystem and we can achieve the entire CI and CD, continuous integration and continuous deployment. If that happens, we are the rockstar team. We're like Barcelona or Real Madrid if you follow soccer, right? We are the best team. And is there any team who does that? 80% of the company wants to get there. Are they there? No. But by learning this, you have already learned this. You just by just understanding this, you are an engineer right now. Trust me. Trust me. People have been working in the industry, and I've traveled around the world to teach people this at this different level, right? I'm teaching you right now. I feel like I'm, knowing the fact that you are non-technical, but when I teach corporates, it's a different ball game and different way and approach. But I've been around the world teaching people this best practice, especially the testing piece, that and how efficiently you should write your test cases, how efficiently you should do automation, what are the tools that you should choose, how you should write the automation. That opens an entire another discussion, and that's where I'm gonna get you slowly, right? Because we don't care about this. We understood the whole point of the DevOps. That's fine because we're gonna live in this. But who we are end of the day is testers. Who we are, who we will be, automation tester, SDAT. And we will be a better automation tester so that we can effectively implement our automation into this DevOps pipeline or this flow or the CI/CD pipeline. So we can achieve this faster automated code deployment from point A to all the way to production. So we comes as a tester, right? So what I was saying, that I gone around the world and teaching people this, and I figured the people who have been working in the industry for, let's say, 15 years, They don't even know these. They don't even know like 20% of these, which you already saw today. That's because the model itself, it's very new. It just came in the market like literally not more than 5 years ago. And many of the companies, mid-size or even large size governments, right? They know the benefit of it. Now, even I showed you, even you know the benefit. If I can implement in a software company, then we are rockstar. The moment developer writes a code, checks in the code goes through all the deployment process, gets automatically tested, done, and boom, goes to production. And the next one, the next day, automatically goes to production. Maybe the same day, developers 2 checks in, creates a new build, get tested, goes to production. Developer 3 checks in a new build, new code, get tested, functional, smoke, regression, automation, integration, and dump into production automatically. Who doesn't love these? Who doesn't understand the value of this system, right? Even you do, they do. But the reality is, to every system, because the corporations that you're going to work for, let's say government, homeland security, right? They've been there for last 50, 60 years, their infrastructure, and they're old, they're so large and vast, right? And they cannot just rapidly moved everything and de-scope all the system they have and come up with doing the DevOps, because they need this infrastructure to do so. So everybody understands the value, everybody wants to do it, but not everybody is there yet. And that's the transition from legacy system or waterfall process to agile and DevOps process. So point what I'm saying, I started giving you corporate lectures, but point what I'm making is, by just explaining these the way I am saying, if you could just explain it to them, they would think you are a rock star engineers, and that's your goal, right? To rock them in an interview so they hire you. Let's say you don't understand anything, just talk like that, just talk DevOps, talk all of these, watch this video like 10 different times after these, and take notes and prepare your story that you had this process in your projects, and I'll see how anyone stop you from getting a job. All right, that's the magic of it, right? So um so to do so, now let's get to the action. I'm going to give you opportunity to ask question in a moment, but let's get to the action before that. So now that we know that we have to be this rock star engineer, so what we have to learn? We have to learn, we have to be an SDAT, that's for sure. So in order to be an SDAT, we need to learn, first of all, we need to learn what are those testings all about, because we're testers first, and then we are automation tester. First, we're functional tester, then we are automation testers, because we know how to automate. So we need to learn each of these testing, what they are. And then we need to learn Selenium, Appium, some tools that is going to help us to get this automated, right? So very clear where you fit in the big dot. Now, automated CI/CD pipeline. What is this? Like, remember I was talking about a tool will do it. So what is the tool? The tool is this guy called Jenkins. Jenkins is a tool. This is the logo for Jenkins. Jenkins is a tool. It's a tool, right? It's an online tool like Jira, right? The tool will be hosted, located in AWS server. Now, what's in AWS? It's you all know it's cloud. AWS, Amazon Web Service provides the cloud solution. What they do, out of the many services they have one called virtual server service, meaning that I can just buy a virtual computer from them. Let's say if I want to buy a server right now, I need to buy a lot of RAMs, a lot of machines, big room I need to rent. You've seen a server room. I've shown you before in this class. So instead of doing a physical server, what Amazon does, gives a virtual server. It'll be like, we have computer, you can just use half of it or just a portion of it, right? For your whatever you want to do. It's a computer for you. I'm giving you access. You don't have to buy a new laptop or new machine. Use ours. That's what Amazon does as a cloud service provider. So the benefit is cost. You're not buying new machine. You're just only paying for the time that you're using. But that's the cloud is a different discussion. You'll get to learn. But what I'm saying, the Jenkins is the tool, and the Jenkins will be installed into the cloud. And who will manage those tools? Who do we have? DevOps engineers. Not your job. DevOps engineer will manage all these tools and set up installations and everything. So what you need to know is that Jenkins is the tool to create those automated pipeline or automated deployment task. So this is how the pipeline will look like. This thing is commonly called CI/CD pipeline in the industry. Okay, continuous integration and continuous deployment pipeline. You understood the concept of continuous integration at the slide number 3, and you understood the concept of continuous deployment at slide number 4. Now, in order to in order this whole thing to come true, you need a tool, and you need to give that tool a set of instruction, like I was saying, that hey, deploy it here, run the smoke test. If it pass, then deploy it to functional test environment, run the functional test. If the test passes, then only you go to the integration environment and deploy it. If the test fails, any of the test fails, then don't deploy. There's no point of deploying a defective code. Then you send me a report so I can check them, and I can create a defect to let my developers know. So see, I need a tool, and that tool is Jenkins. Okay, fine, I know it. Now I need to give Jenkins these instructions. So that is what the pipeline is all about, CI/CD pipeline. So CI/CD pipeline is it's a process within Jenkins. It's all about how we are telling Jenkins to create this pipeline with the set of instruction that we are giving to Jenkins, right? That's it's all about it. That's all you need to understand. So but I'm going to show you what essentially happens within the pipeline. So AWS, I'm not sure why my mouse is acting up. So let's try it again. Perfect. So you see we have Jenkins. The Jenkins will be hosted in AWS EC2 instance, and then Jenkins knows where the code repositories are, because let's go to the server. Let's go to the environment. Every environment has a repository, and this is where the code are residing. Now, point to understand is there's two types of code. One, what came from the developer to build the story. That goes to the build, and that build comes along here, here, here. So that there's a repository where the developers code are here. But then this repository, excuse me, also has a different branch, right? Within the repository, you can create different branch. One is the dev branch, and then one is for your branch where you're gonna keep your automated test, right? Your automated tests are also code written with the Selenium and Java. So it's all in the GitHub repository. How, what, you will all learn that in part of the automation classes. That, but just understand that you need to tell Jenkins that where is your code, automation code, and where is your application code, right? So that's what I'm saying. When you create the instruction, a pipeline, you are saying, hey Jenkins, here is my code, automation code, and here's my application code. So GitHub, you see, this is so easy. In the GitHub, I have multiple repositories. If I just go into the repository, it gives me a very unique link. So I can just tell GitHub that, hey, GitHub, my code is in this repository. And I have two branch, master branch. I can create more branch that automation branch and master branch, development branch. Um, However, let's not get into so details, but this is the logo for GitHub. All I'm saying that I am letting Jenkins know, let's go to GitHub, and within the GitHub, you have my application code and the automation testing code. And then I'm telling GitHub, hey, I'm telling Jenkins, hey Jenkins, here's the code. Just check the code out to a computer. I need a computer. Where is Jenkins gonna run the test? So Jenkins needs a computer. So I'm saying where it is in remotely repositories, and then I'm saying once you find the code, check the code out. The whole repository check out into a computer. That means now Jenkins will come here, and whatever the code it finds here, application code as well as the automation code, I need to give Jenkins a computer, link this computer with Jenkins pipeline so that Jenkins every time checks out code into here. Now, where is this computer? Is it your laptop, my laptop? And I can have a physical computer just keep there all the time where I know that nobody is going to use it. Jenkins will use that. Jenkins will check out all the codes here and run the automation test and build the software and run the automation test. Right? This computer is also in AWS. Remember, AWS is providing EC2 instances. That's a service, meaning it's providing you virtual computers. Before AWS, before the cloud come in, you actually had to buy this computer, a laptop or a physical device. Because of the cloud computing, now we have opportunities, so we don't have to buy different devices. We can just use their service to do so and destroy it. How? That's a big question. Let's not get there. Just understand the concept. So the Jenkins will go and check out all the code. And then we have a tool called Docker. Within the Docker, you have Selenium and Appium, right? Selenium is used for testing, automation test into all these different browsers, right? For say that you want to test Amazon, or no, sorry, you want to test Transfotech Academy, a build you want to test. Now, when Jenkins deploys the build here, you want to do a functional test of those new build, those stories that are in the build. So let's say the build is all about, this build is all about testing this link. Then I'm going to go to IT training, and it should kick up the new page. And I should be able to read the 6-step process, the unique 6-step process of Transfotech, and I should be able to go to apply now, and it should come. It didn't come, but a lot of defects with Transfotech's website is being built right now. Let's say I'm going to go to see details, and I should be able to see details of the course. That's the testing. So when you are telling Jenkins here that when the bill comes, do that testing, but let's say you have an automated test. Now my question is, what browser you're going to use? You got 4 browsers: Safari, you have Firefox, you have here Google Chrome, Firefox, Safari. This is also Safari. It's supposed to be IE, Internet Explorer, and then Opera. Now let's say that you have the test automated. Fine, you have the test automated. Now you want to execute it. But then don't you need to execute into all these different browsers because you're not sure that what browser your customer is going to use? Maybe it works on Firefox, but it doesn't work on Chrome. Maybe it works on Chrome, it doesn't work on Safari or IE. You see, there's no way for you to know. Maybe it works on Windows computer because it has Google Chrome. But let's say that your customer has Mac. There's a huge percentage of the customer uses Mac. So we have to test it the in Safari also, right? In the Mac's browser. So if we don't have automation, then we have to do the same testing 4 times in 4 different browsers. That's also a problem. So automation saves a lot of times and efforts. So these kind of testing calls cross-browser testing, cross-platform testing, where you where you execute one test cases across multiple platforms like Windows and Mac. Now, so in these pipeline, when I'm saying Jenkins, check out the code into a computer, and then I have something called Docker. It's a containerization concept. I'm not going to tell you what it is. Let's just it's a tool. Let's say we have it, right? So what is going to happen in this machine, the Jenkins will create a new Docker image. And within the Docker, we have Selenium WebDriver installed. We have APM installed. These are the 2 different tools that you need to learn. Selenium will give you the ability to automate your test and execute into all these 4 or 5 different browsers. And APM will give you ability to execute a test into the mobile devices. Now you are covering your devices and laptops. So you don't know your customer might be in iPhone. You don't know your customer might be in iPad. So for you, what's important to understand here is you need to learn Selenium WebDriver with Java so you can automate your test, and all the browser related test gets automated and gets done by Selenium, and all the device related test gets done by APM. So if you can just learn these 2 tools, you will be a rock star QA, and that's basically your job into these pipeline, right? Setting up this pipeline it's a job by the DevOps engineer. What is your job is to create those tests using Seleniums and APMs so they could be part of these pipeline. When you write those automated codes, they will be also kept in GitHub. So when Jenkins checks out everything in here, and then Jenkins will find your automation test, and then start a Docker, start Selenium Hub, start APM, and whatever the automation code you have run, Jenkins will run all of these into a Docker image, meaning in this computer. So your test is getting automatically executed here into multiple devices and multiple operating systems and across multiple browsers. And then once everything passed, then we have another tool called Ansible. That is the tool for the tool is responsible for doing the deployment, pushing it through the next environment. So this pipeline is nothing but a process done by Jenkins, managed by DevOps engineers to give the instructions, so where everything could get done automatically to the production. From the developer checks in code, the moment the code comes in, Jenkins gets activated because you have created a Jenkins pipelines like that. DevOps engineers create a Jenkins pipelines like that. So DevOps get activated because DevOps is connected with your repository. See, a Jenkins is connected with your repository. See, so when the code comes into the dev repository, Jenkins sense it like, hey, code came. All right, let's get activated. So what we do? Let's get the whole code from here, checks out into Amazon EC2 computer, and then run all the smoke test. Run where? Run using what? Selenium. And then when all the test passes into multiple browsers, then do what? Ansible. Jenkins has Ansible too, right? Jenkins plugin. So Jenkins will be like, okay, now all the tests pass. Go ahead, Ansible deploy. Deploy to here means the test environment. So when the test comes here, the next Jenkins jobs will kick out. The reason we called it a pipeline because there are multiple Jenkins jobs linked together. So the next Jenkins jobs will kick off. And next Jenkins jobs will only kick off when the code comes to the test environment automatically. The code comes into the test repository of GitHub. Jenkins will sense it. Jenkins will be like, oh, great, the code now came here. All right, next job gets kicked off. So what to do? All right, execute all the functional automation test. Execute through the Selenium WebDriver into all these browsers. Execute all the APM test into all these browsers. If all the tests pass, hey Ansible, go ahead and deploy into the next environment. And when it comes here, same thing. Checks out the new repository, run all the regression tests again automatically. Go to boom, next one. And so this pipeline is very important, and that is done by Jenkins. If you ever be, if you didn't understand like half of the things that I've said, that's okay. You don't need to. If you understood like 50% of the thing that what I said, and at least got to see the logo colors and Selenium WebDriver colors, I'm happy. You're good. You're good as an automation engineer. I'm not expecting you to learn everything, but at least you saw things, and you're gonna have this video to refer to. So if you ever want to be a DevOps engineer, that's their job. So now you know what's a developer do, what's an automation engineer do, and what's a DevOps engineer does. These three guys together set up a culture of DevOps, set up a true agile culture by implementing a CI/CD pipeline, by implementing the DevOps culture, and by achieving the agile mindset, right? That's what I can say. So now you know that all these three roles, how they're different, what they do, and why they do it. We all work together to deliver frequent code with the best quality with the help of automation. Um, yeah, so I'm going to take a pause. I don't know how many of you ran out. Oh wow, nobody ran out. Wow, that's a surprise. So I'm just gonna open up for questions. Take a pause, and if you don't know what to ask, I don't know where you stand. I like to talk to you guys. Tell me, how was it? Did you get anything?
Little bit. Yeah. Some get some idea and knowledge.
Okay. Was it hard to understand?
No.
Like, it's a kind of, but if we go through again, we I think we can learn.
Okay. All right. Some other feedback?
Can we go with this in this program? Can we learn in APM or not?
No, 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 that's not my goal to teach you FPM. It's going to take a lot of time. So that's an addition to your career. So
Oh,
basically, you're focusing on the
Selenium.
Selenium piece of it. Selenium, but the very high extent of Selenium that you'll be able to integrate your Selenium test with within these pipelines and things like that. These mobile testers are different.
Gotcha. Thank you.
So we will be learning how to do test cases and the different codes for Selenium to be able to automate all of this, correct?
Yeah, so let's set up that stage from here. I think it's very important that you guys will be watching this video a couple more times over this whole week, having better understanding, clear out your doubt in googling, YouTubing, different DevOps things, and you'll see better videos, short videos. That was very details class today, but you'll see short videos from a different perspective done by different people would give you more ideas to clear out your doubt. So you do that. But where does this leave us, right? For next classes, so that we know our job starts with the software STLC starts with writing the test cases. So we need to learn that. But before we write the test cases, we actually need to learn these different types of tests. Then only we'll be able to write the test case, right? So once that's number one. You learned the DevOps this week, and you also learned these different types of tests. When we come to the next class, we will talk about the different types of tests in the next class. After that, we will talk about how to write test cases for each of these different types of tests. Okay, so two things we'll learn: how to write test case in Jira, and we'll also learn how to write test cases for each of these different types of tests manually. I'm talking about manual writing test cases. Then we'll talk about how to execute these manually. We're not going to do these deployments and all of this. This is just for you to understand today. But we will start the next classes. We will write test cases. We'll execute test cases. When the defect comes, we will log the defects in Jira. That will be your learning curve because you need to learn that as a tester. Then once you're done, you're good to go. There's nothing else. You're good to go, right? Then there will be a student presentation, right? All of my previous batches has done it as part of the course. I'm going to create two groups among you, and uh, I'm going to give you a week to come up with the, maybe I'll give you a topic. Maybe that could be a continuous integration in your last company. You know, prepare, do teamwork, prepare some sort of slides and present. So some sort of topic will be given to you, and you're going to be participating in a group presentation. That's next, after you learn how to write test case and how to learn all these different types of tests. So that's kind of next two to 3 weeks. After that, there's nothing left. Now you are fully ready to start learning either automation, right? Selenium, and start automating those test cases. First learn Selenium, learn Java. So in order to learn Selenium, first you need to learn Java, right? Not so depth, like at least 5-6 classes will be there, and then you learn Selenium, and then you will see how to automate those test cases. And then you'll see slowly at the later part of the automation class, you'll see how to create this pipeline, at least the testing piece of it, right? Setting up Jenkins, how to work with AWS, and all these cool things you'll learn. Everything that I'm showing you here, you'll get to learn this, right? That's a later part of your automation test. Maybe after that, you will go to the database test, or it could happen that before you go to automation, we put you in a database class. These are separate pieces. You need to learn automation, and you need to learn SQL at the database class. With these two different pieces, it will make you a full stack engineer. And then there are a few more additional pieces out there: API testing, performance testing, cross browser testing, mobile apps testing. Each of these different topics will have a class. Just to give you an idea, and not just to give you an idea, just to give you enough to know what it is and how to do it, but not at this extent of automation that you're going to learn. Does that make sense?
Yes.
Yes.
So fun begins. No, no, no more wasting time. No more missing classes. This is where it's gonna get technical. And you have two routes. If you practice and you go along the class, it's gonna get so smoother for you, or it's gonna get so ugly for you if you don't practice and don't go along, that you wouldn't get anything after that. All right, so switch gear up, change gear. Now you're on the highway now. You were on the local road until this time, and now we're in the highway. Switch gear up, and I'm gonna give you 5 more minutes to ask question. If you don't have any question, then the I'm gonna talk about the homework. The homework is all about agile practice, CI/CD pipeline, and different types of testing. I'm gonna give you a website to do so. Actually, I'm gonna show you right now. I think I found To learn different types of testing, you can Google it, but I found Guru 99. A lot of people initially learns software testing, uses it. So if you go to guru99.com and go to software testing, there is a lot of readings in here. I think I gave you before. So it's just one more time. The difference between different sort of things for learning purposes is really good, just to fill out your brain with the various different informations. So go learn different type of testing from here. All of them are here. Okay. I'm gonna give you the link in the LMS as well.
I think you already sent this before.
Right. Just putting things in perspective one more time. So now with these, what question do you have?
Quick question. For Ansible and the New Relic, is that the same? That's the end of the after the our jobs, then it goes to the Ansible. Is New Relics the same with that Ansible?
New Relic it's a part of a performance side of the performance side of the tool for pipeline, for creating new reports and everything. These are tools that create solution, but there are variations out there in the market. Not every company will use Docker. Some companies use Selenium Hub, Selenium Grid. There could be different solutions, but everything is done through Jenkins. Um, so if you look at these, is there are AWS, Jenkins, GitHub, Docker, Selenium, Ansible, New Relic. These are 8 different tools, creates the whole solution. And some companies don't like Ansible. So people like, there are Puppet and Chef, different tools for the DevOps. But do you really want to get into that world? I don't want you to get sidetracked, okay? Because there's no ending of learning. So I really want to bring you guys focus on test automation and testing. That's your landscape.
Yeah, I just want an overview of it.
Yes,
Thank
just
you.
fun. But don't get too hung on this. Okay, this could be different tools to design this pipeline. If I design it, I'll design it this way.
I have a question. So for our course, the QA tester, we have to mainly focus on the functional test section, right?
Yes, here, functional testing, all these different kinds of testing, how to write test cases, how to log defect, and then how to get this automated using Selenium. So Selenium, Java, Selenium would be the heart for your course. And then Adam will come and teach you the database stuff, how to test database server, SQL. That's also a very crucial piece. I don't want to ignore that. That's also a crucial piece. But you will be an agile tester. First of all, you would be a functional testers who knows how to work in an agile environment, how to work in a CI/CD DevOps environment. So you better learn Selenium well.
Is Selenium is part of the curriculum? Okay.
Yes,
Alright.
Selenium is the heart of the curriculum.
Okay. Thank you.
Okay, so I think I don't know if I have the PDF here for QA testing. No, all right, now. Do I have a QA curriculum? Yeah. So now that you know much better, now that you are in depth in the course, I'm going to show you the curriculum one more time. All right, let's come here. Don't get scared though, okay? This is just a 4th class. So we're here. We learned about SDLC, STLC. We learned about agile software development so well. I showed you GUI. You didn't really learn it, but you will. but you learned about different types of testing. But you know, we've covered Jenkins continuous integration, DevOps concept, EC2, some of these, GitHub, right? See, I'm not going really with with this syllabus and anything, and I'm actually going with the syllabus, but I'm just taking some carves, whatever comes necessary. So I think after this class you'll feel more confident at a foundation level now that you see the clear picture. I've also talked about cross browser testing with cross browser testing. Now that kind of lays out a foundation for you. From this point, the next few classes you'll see that we'll start database testing here, right? This card, and then after that we'll start the automation framework development. In order to develop automation framework, you're going to learn Java and Selenium. And then once you have good knowledge in these, and then you learn developing a TestNG framework. That's one framework of Selenium. And then there's Cucumber and BDD. It's more popular and the newer framework that you're going to learn. See, now by the time that you finish your automation, you'll come here. And the rest is, you already understood that the GitHub is the place where we keep the code, and then continuous integration happens, DevOps happens, AWS happens. This is where you're going to get hands-on, right? So we have classes for that. So if you look into the thing, all these things that we talked about, creating pipeline, all these things that we talked about, CI/CD, in these classes, you're going to get it done. You can already see the Jenkins here, continuous integration, DevOps, AWS, all these things that you can implement here. And then I said there are a few more classes: performance testing, API testing, and Linux. So there's nothing that we left behind to make you a full-blown, full engineer who's capable of working in a DevOps and Agile environment. I need your commitment from this point, okay? It's gonna be a little bit, but it's worth. You're gonna sustain in the industry for the next 15 years. You're gonna be on the top of it. People respect you. People love you because of the work you do. So switch gear, put some extra time from now on, and let's go along with the course. The new people who have just joined, you should watch the old videos as well for a couple of times.
Yeah, I definitely have to watch all of them again, over and over. Thank you.
Yes. Yeah, sure. You have time. I mean, who's stopping you? We gave you the videos and everything. Just watch. Any more question today?
Can I ask you the simple question?
Mhm.
Like test case is right before the product owner, or we can the tester write it?
Right before the product owner.
No, the when the like the make the ready product, I think product backlog. That time they will prepare the what can I test, or we can create the test with tester. Actually, who can make it the test case writing?
We do. Tester does.
Yeah, but what kind of question who make? We can make it, or somebody make for us?
You have to ask the question if you don't understand. Now let's go back to the Scrum process, right? What we talked about, that the product owner will create the product backlog with the BA. Now the product backlog is nothing but the stories in there, right? Now at the sprint planning meeting, before the sprint starts, at the sprint planning meeting, you take a chunk of the product backlog and put it in the sprint backlog. These are the stories that you're going to do within the sprint, for sure, right? Now, these stories are written in Jira. Who have written this? BA, right? So the BA has written those stories. So all you have to do is go to the story in Jira and read the acceptance criteria. And from that acceptance criteria, You will write the test cases.
Oh, okay. Okay. Got it.
Right. Now, if you have any questions about an acceptance criteria for each of the stories, you definitely bring it to the stand-up meeting, because you have stand-up meetings every day, right? Let's say this slide, right?
Yeah,
The
the
product
system.
owner giving clarification, and then when sprint starts, you have the daily Scrum meeting. You can ask it there, or you can set up a different time with the product owner or BA. But you have to write the test cases. That means that you have to have understanding of all of these stories. You need to, stories are written it's not a big task, big deal. Okay, stories are written in Jira,
Okay.
and the BA will write it nicely, because BA is a trained person. He knows how to write, or she knows how to write, and BA will write those acceptance criterias in a nice way so you understand. But still, if there's any question, you can go back and ask.
Okay. Yeah, I got it now. So that like acceptance criteria is the main thing.
Acceptance criterias are the main thing, and then from these let's go back to our slide today. Where is that? Okay, how developers are also writing code for each of these stories, and these stories are not these. Hold on, these are the stories. Whatever the stories gets picked after the sprint planning meeting, that's what your developers are developing, right? That's what your
Yeah.
developers are developing within the sprint. So how do they understand that what story is all about, that they have to start writing code to develop it? Same way you have to read, same way you have to understand the story to write test cases. So now if you have
Yeah.
question, you can always consult them, because he also had to, understand this. Without having a proper understanding of the acceptance criteria, he wouldn't be able to start writing code. So now BA's job is to write the story here in Jira so clear, write the acceptance criteria in a way that it's really understandable. That's your BA's skill, right? If I be a BA, I would
Yeah.
write it in a way that everybody understands. Because if they don't understand, then that's going to kill a lot of time, raise a lot of questions. So
Got it.
it's not a hard job, bro. It's not a hard job, QA. It's just of having the proper foundational understanding right. If you do, then you'll find a sweet spot. You become a manual tester, or you become an automation engineer, and you just do. If you're an automation engineer, you just do testing. That's it. I mean, you just do automation with Selenium.
Okay. Thank you.
I have a question. The test cases, they're written by us, but is that done in Jira as well?
Yes, that
Okay.
every documentations that you produce, that's in Jira. Stories are in Jira. You write test cases in Jira. You write defects, they're also in Jira. So Jira is in one tool where we write everything, so that we can link them together, we can keep them together. We have one centralized place to manage all of our documentation during this project, right? Simple as it is. Like, we manage all the codes in one place in GitHub, right here. But that's for code management. But then we have Jira for documentations and artifacts management. Both are important. So
Perfect.
first we
Thank you.
produce documentation, documentations, and then we produce codes. Yep.
Thank you.
You're welcome. And thanks for asking all these questions, because that's kind of, everybody's learning from it. All right. Now, if you don't have any more question, I need some feedback from you guys for next 4 minutes. I know you guys are 10 people and you come from different background with having with different foundations about IT. So, how hard was today's class, or how was today's class as a whole? Was it funny? Was it easy? Was it so hard? Give me some feedback so I know where you stand and where I stand.
I definitely feel like it's informative to know the background. And it's going to help us like in the future to understand all of this. But I do think that it is important to go back through the video and then also to read other things like on the Guru 99 and stuff like that to get a better understanding of it all.
Right. But thanks for your feedback. But while I was explaining everything, were you able to pick up the most of it or the gist of it?
Yeah, definitely.
Okay, that's good to know. All right, thank you.
I'd like to comment that it's really good to have a visualization, which is you did a very good job on doing this visual of IC city and all this drawing, so that we would have that overview what's going on of that certain departments that connected with us. So that is very helpful.
So you understood everything. There was no issues with picking up. You never felt lost at some point.
No, but I could only uh, put it on my end, on my opinion. I do understand everything from, and if I don't, that's why I'm asking question. But with a lot of clarity right now, I do understand. I know that Jenkins is also the same as Jira function, but in DevOps, environment. So it's not hard to understand it. I'm looking at it with this visual plus your explanation, which is very good. That's just a comment.
Thank you. Helpful. Thanks. Next. All right, give me a few more.
Yeah, the visuals definitely helping me to understand more. And you're explaining very good, so which is very helpful. Plus, of course, recording of the videos we can always watch later. Thank you so much for that.
Right. This is your first class today?
I was here last class, but I haven't even I didn't get a chance to look at it. But after today's class, definitely I'm gonna go back and look at all the classes that you gave.
Right, but my question
Yeah.
is, you didn't find it very difficult to understand today's class without having
No.
really, no?
No, you explained very nicely,
Wow.
and I think once I go back and look at your classes, previous
It'll make
classes,
more sense.
yeah, it will be, yeah, because it made a lot of
Well,
sense to me
that's
today.
good. That's good. That's good to hear. That's good. That if it was not hard for you to understand, I think the rest of the people would at least get the gist of it. But if you watch this video a couple of times, it like
Yeah, because
there's
they've been here from the beginning with you, and I'm here like today 100% with you. Like last class too, I wasn't here 100%. So yeah, thank you for that. Yeah, it's
all right.
easy. Hopefully
Thanks a
it
lot.
gets easier.
Yes, I'm just gonna ask a few people that I think Rashmi, how was it?
Good.
It was a little tough.
No,
Okay,
I
you
I just need to watch one more time. Then I'll be.
yes, yes. Cool. Rashid, how was it?
It was good. I was able to like understood like the way you explained and especially the slideshow, like the presentation of it. It was more detailed, and as you explained, it was good. I was able to understand.
Very good. Zahira, you there? You never spoke, so I'm just picking on you. Maybe Zahir doesn't have a mic or something, but yeah. So that makes me feel better. That's awesome. Good to know. All right. So move on. Let's have the next class next Saturday at 11 a.m. Okay, and we
Is
will
it
be
Saturday or Sunday?
Sunday. I'm sorry, my bad. Of course, Sunday. We will be talking about different types of testing, and let's get into our pod. Right? We've seen the whole world. Now let's go to our pod and let's start doing some testing. Right? Start writing test cases. Start writing test cases in Jira and start learning about different types of tests. In the
Class
meantime,
is
if you can
every
come ready,
Sunday,
that'll
right?
be awesome.
Class is every Sunday.
Classes are every Sunday. Yes. And who is this? I
Nurul
can't.
Huda Rubel. Yeah, this is
Oh,
my first
Nurul.
class.
Yes, you've joined today. Good.
Yes. Actually,
Oh
I
yeah,
saw the video previously. You know me? Yeah.
I
Last
think
video.
I've seen you. So as a new person's joined. How hard was it for you?
Yeah, it's good. Today is my first, class, but I saw already, previous
The other
videos. So
videos.
yeah,
Okay.
we finished all. So this is good.
Very good.
I saw the future. Yeah.
That's good to know. All right, I'm gonna bounce
Yeah.
off right now, and I hope that you guys will keep it safe and stay happy. And till next week, I'll be probably in a different geographical location because I'm flying. Um, I'm flying on 25th, so keep me in your prayer and see you next Saturday. But that
Thank
doesn't
you.
mean
Have a nice
anything. We
weekend.
are in a global world. Yeah, you too.
Thank you. Have a nice day.
Bye bye. Take care.
Okay, see you next Sunday. Thank you.
Thank you, guys. See you next Sunday.
Bye bye. Thank
Bye.
you.
Have a good day, everybody.
Bye. Thank you.
Bye
Thank
bye.
you.
You too.